Let's take a look at this second midterm. First question is asking me to find the particular solution. So we have two different ways of finding the particular solution: unknown coefficients and variation of parameters. This one's going to be variation of parameters because there is no good guess for secant of t. And I think we did this exact question in the notes. So we got to get our particular solution. We're doing variation of parameters. So our particular solution is y1 v1 plus y2 v2, where the v1 and v2s are given by those formulas. So we need, in order to fill in those formulas, I need y1 and I need y2. So the auxiliary equation, lambda squared plus 1 equals 0, is giving me lambda equals plus or minus I. So our two solutions then are going to be sine of t, and y2 is going to be cos of t. So we need y1 prime which is the cos of t, and y2 prime, which is minus sine t. And we can build the Wronskian with that then. The Wronskian is going to be y1 times y2 prime, so minus sine squared minus cos squared. So the Wronskian is equal to minus 1. A is equal to 1, and the g of t is equal to secant t. So we can fill these pieces in here. We've got g of t, y2 is going to be cosine of t. The Wronskian, a is 1 and the Wronskian is minus 1. So I'm doing this integration. The minus and the minus are going to cancel out. Well, let's finish this. Secant is 1 over cos. So this is just integrating 1 dt, which is equal to t. Our second integral then, filling that in, g is still equal to secant. There's no minus in the v2. Y1 is equal to sine. And again, a times the Wronskian, there's minus 1. So now this one, I'm integrating sine over cos, I'm integrating minus tan. So integrate minus tan t dt, which is going to be minus the ln of secant. Some people brought the minus inside, made it minus, or made it the ln of cosine. That's fine as well. I'm going to keep it as minus the ln of secant. So finally, we can put those pieces together. The particular solution is t times sine. That's our here, t times sine, times cosine. There's our particular solution. If you wanted to solve the whole thing, you would just add then the homogeneous solution, but it didn't ask for that. Next question. The next question then, this is just plain vanilla, got to get the homogeneous solution, got to get the particular solution. After we add them together with the general solution, use the initial conditions to get the c's, the two c's that are in the homogeneous solution. So write down our auxiliary equation. That factors, we get eigenvalues of minus 2 and minus 2, real and repeated. So our homogeneous solution is of the form c1 e to the minus 2t plus c2 t e to the minus 2t. Now I need to get the particular solution. And as in question 1, we've got two different ways to get the particular solution, but this one I can do with unknown coefficients, just a e to the t, e to the t. So I think that's the way I'm going to do that one. Now, because my target function is a number e to the t, my guess is a e to the t. Now, the derivative of a e to the t is a e to the t, the second derivative, all the derivatives. So when I sub this in to the left-hand side of the equation, I'm getting y prime prime plus 4y prime plus 4y is equal to 18 e to the t. I'm setting it equal to my target function, and that gives me a is equal to 2, because this is 9a equals 18. So the particular solution then is 2e to the t. So now I've got my general solution. The general solution is going to be homogeneous solution plus particular solution. And it's at this stage, then I have to get the c's. So when I make t equal to 0, I can set this function equal to 3. Then when I set its derivative, well, let's do that then. Let's get those c's. When I make t equal to 0, that's going to be c1, e to the 0 is 1, plus c2 0 times, so 0, plus 2. So it looks like c1 is equal to 1. So now my general solution, I'm just going to take this, copy, and I know that c1 is equal to 1. Now I need its derivative. So y prime is equal to minus 2. Let's do this. When I take its derivative, that minus 2 is going to come down. Here I have to do product rule. So derivative of the first, leave the second alone, plus leave the c2t alone, times the derivative of the second. That's going to put another minus 2 out front here. I still have a e to the minus 2t. And the derivative of 2e to the t. Now, I set that equal to 6 when I make t equal to 0. So that's going to be minus 2 plus c2 minus 0, because of the 0 that's here, plus 2. And that means that c2 is equal to 6, because this plus 2 and this minus 2 cancel out. So, final answer, with the 6 here. Next question. Okay, this was we write the linear. You want to find the differential equation that has the particular solution of 2e to the t. So this has got to be the particular solution. They're giving me the general solution. So this is the homogeneous solution. The eigenvalues must have been plus or minus 3i. So that means if the eigenvalues must have been plus or minus 3i, the auxiliary equation must have been lambda squared plus 9 equals 0. So that means it must be prime prime plus 9y is equal to, well, is equal to what? This would give me the auxiliary equation lambda squared plus 9 equals 0, which would give me the eigenvalues plus or minus 3i, which would give me this as the homogeneous equation. What about this target function? Well, they give me the particular solution, 2e to the t. So when I put the particular solution, its only job is to go in this left-hand side and hit the target. So if the particular solution is 2e to the t, then y prime prime is 2e to the t. So I can sub it in. 2e to the t plus 9 times 2e to the t, that's 20e to the t. So there's the differential equation. That answers the question. Some people went on and solved it, but you didn't have to. In fact, you already have the solution there. So let's take a look. Oh, what's a thing that people didn't do, though, that you could have? You've got the differential equation. You could have also given me the initial conditions. How? Well, you've got the solution here. If I put t equal to 0, I get 3. And if I take the derivative of that, I'm going to get minus 3 sine 3t and 2t. And if I put 0 in that, I get 2. So for to be extra good, you could have given me the 2 initial conditions. But this is what I was looking for here. All right. The spring question. We just want the differential equation here for this spring question. Now, differential equations for spring is mass times y prime prime plus coefficient of friction times y prime plus spring constant times y equals a forcing function. So we have all those pieces in there. A 1 kilogram mass, so 1 times y prime prime. The coefficient of friction is 3 times, thrice, y prime, plus spring constant of 2 is equal to the forcing function. So the forcing function is some outside force, someone pushing on it. So that's the answer that I wanted here for A. You don't have to solve it. How damped is the solution? Well, the choices are overdamped, critically damped, and underdamped, and it all depends on the eigenvalues. Since if you write down the auxiliary equation here, lambda squared plus 3 lambda plus 2, you'll find that it has 2 real and different roots, so overdamped. All right, this next question, this again, I mean, some people went into, did Laplace on this, but we didn't need to use Laplace until question 6. I'm going to solve this using the standard chapter 4 way. We got our auxiliary equation. I just need to solve for lambda. I get lambda equals, it doesn't factor, so I'm going to have to use quadratic equation, minus 1 plus or minus root 2i. So I know that the homogeneous solution is equal to, now I got 2 different ways to write this with complex eigenvalues. I'm going to choose, not many people chose the one shifted sinusoidal function. Most people chose the sine plus the cos. I'm going to go with the one that people didn't choose much, just for funsies. So a constant e to the real part t times sine imaginary part t plus another constant. Okay, could you guys get out of here? Jesus. It's my cats. All right, now we need to get the particular solution. The target function is a line, so I'm going to guess the most general form of a line. So a t plus b. I need its derivative and its second derivative. Its first derivative is going to be a. Its second derivative is going to be 0. I sub those into the left-hand side of the equation. So 0 plus 2y prime plus 3y, so 3at plus 3b. I set that equal to the target function. So right away, I can see, because 3at equals 9b, that a is going to be equal to 3. If a is equal to 3, then I've got 2a, or 6, plus 3b is equal to 0, because it's like plus 0 on this side. So b's got to be minus 2. So then my particular solution is equal to 3t minus 2. Add them together for the complete solution. The general solution is equal to homogeneous solution. It's got the two constants in it, plus the particular solution. I don't have to find those two constants because there were no initial conditions given, so I'm done. Last question. This was the one for Laplace. We have to unlaplace this, so break it up into partial fractions. I'd skip that part, but partial fractions. And then unlaplace. So that's going to be e to the 3t using the chart minus e to the 2t using the chart. Done.